All right, let's compute some z-scores and then use them to compare values. So we are looking at test one and test two, two tests that you took. You scored a 95 on test one and a 95 on test two. So which test did you score higher on? So you might say, I did the same. I got a 95 on both of them, but these are different tests, right? So they're going to have different values, different means, different standard deviations. So a 95 on one test maybe isn't impressive, but a 95 on a different test, maybe you're above everyone. So by changing and standardizing the scores, right, changing these to z-scores, we can then compare the two tests. Because right now, test one and test two, it's like an apple and an orange. You can't compare apple and oranges. But if we can change both of these tests to be z-scores, if they're both z-scores, now we can compare them. So we know to find a z-score, we need the value, which we have is 95. We need the mean and the standard deviation. Well, we don't have those. So we're going to go and calculate the mean. So average. And for test one, I'm just going to highlight, right, A2 down to A17 and hit enter. For my standard deviation, I'm going to use stet dev, and I'm going to use this as a sample because I don't know that all students took the test. And now I have my mean and my standard deviation. Let's go ahead and find our mean and standard deviation for test two as well. So average, and I'm going to go B2 down to B17, close my parentheses, enter. You can see there's a higher mean on test two. And then I'm going to find my sample size, my standard deviation. So stet dev S again, B2 down to B17, click and drag, and there we go. Okay, so now let's find our z-score. So we know that our z-score, there is a formula for that if you do it by hand, but we can use standardize because to create a z-score means you're standardizing your data. So you'll notice that Excel gives you some hints when you're using formulas. So when I click an equal standardize, you see it says X, then mean, then standard deviation. So X is my data value. That's 95. Next, I need my mean. I'm going to click on E5 and then standard deviation, E6. Close my parentheses and hit enter. So my z-score for test one is 1.00965. So I'm roughly one standard deviation above the mean. That's pretty good. Okay, so now let's look at a z-score for test two. So I'm going to do standardize. Again, change to a z-score. I'm still looking at an X value of 95. My mean is G5, and then my standard deviation is G6. And I get a z-score of 0.915997. So about 0.92 standard deviations above the mean, which means technically test one is the winner. Test one is where I scored higher because I scored higher, like more above the mean than I did in test two. Both of these scores are great. They're both, above the mean, above the average, but in test one, I was more above average than on test two. So that's a way you can change things, right? Standardize scores from two different pieces in order to compare them using z-scores.